Hey guys, welcome to the first video in the LearnAPCalc series here at LearnAP. Before I get started, I want to remind everybody that we do live streams every Sunday from 4 to 5 p.m. Eastern, where we answer your questions, so be sure to check those out. Also, if you have any questions, please leave a comment. I'm active in the comments, so be sure to ask a question if you have them, and I'll help you out. Alright, well in today's video, we're going to talk about an overview of functions. So we'll talk about notations you should know, domain and range, odd functions versus even functions, inverse functions, functions you should be familiar with, exponential and logarithmic functions, log rules, trig functions and identities, and inverse trig functions. Although this stuff is pretty basic, much of this stuff is really fundamental, so it's important that you understand the material I'll be covering for the AP test. So without further ado, let's get to it. Alright, so let's start by talking about domain and range. A function's domain describes the numbers that x can equal, while a function's range describes the numbers that y can equal. So let's say we have some function, let's say y equals 1 over x. Let's find the domain and the range. Now in general, we should start by finding the domain and then the range. So this is a good rule to keep in mind. So to find the domain, let's ask ourselves, what numbers can't x be equal to? Well, in this case, all real numbers will work for x except for 0. So to write out the domain, we're going to start with this open parentheses and write negative infinity. And this is the lowest number that x can equal. From negative infinity, we can go all the way up to 0, but we can't actually get there. So we'll write 0 and then another parentheses. Note that the open parentheses means that the value is not included, and the square bracket, like so, means that it is included. So here we can include 0 in our domain, because that would mean dividing by 0. So we're going to put the parentheses. From 0 then, we can go all the way up to infinity. So that's how we write the domain and how we find the domain. Next, let's talk about range. So a function's range describes the numbers that y can equal. And for here, there's a couple of ways to do this, but I find that the best way is to plug in the endpoints of the domain. So here, if we plug in the endpoints, we're going to plug in infinity, 0, and negative infinity. So these two right here are 0. Any whole number over infinity is 0, but we're not actually going to get to 0, so something to keep in mind. However, this 1 over 0 is a little more mysterious, so we're going to have to do some more work. We know that we're approaching 0 from the negative side, so we're going to get very close to 0 negatively, but also from the right side. We're going to get very close to 0, but positively. So I find that a good way to do this is let's plug in some really small numbers that are close to 0, but not actually 0. So since we're coming from the right and left-hand side, or positive and negative side, we'll plug in small numbers close to 0 that are negative, and small numbers close to 0 that are positive. So here this is negative 1,000, and here this is 1,000, excuse me. If we start plugging in numbers closer and closer to 0, this is going to go down, and this is going to go up. So this, we can say, is getting closer to negative infinity, and here we're getting closer to infinity. So now we have the values 0, infinity, and negative infinity. So we just want to write this out. Again, starting from the lowest number that y can equal, going up from there to the highest number, which is 0, but we have to stop there because 0 is not included with this open parentheses. We write that 0 again because we're getting close to 0, but this time from the positive side and going to infinity. And so that's a good way to find domain and range. Again, if you have any questions, please leave a comment and I will help you out and clear up any confusion you may have on this or any topics coming up in the video. Alright, now let's talk about odd functions versus even functions. A function is even when f of negative x equals f of x. This is shown graphically when it's symmetric with the y-axis, shown here on the right, with y equals x squared. Some common even functions, y equals x squared, and cosine. So what this is saying is that cosine of negative x equals cosine x. So that is something that you should definitely know. So you might be wondering, well, what does f of negative x mean? So let's say we have some function, f of x, we'll say x squared plus log of x. All we're going to do for f of negative x is plug in negative x anytime we see x. So we see x right here, we'll plug in negative x, and then that's squared. We see another x here, so we'll plug in negative x. And that's all f of negative x means. Now a function is odd when f of negative x equals negative f of x. This is shown graphically when it is symmetric with the origin. So what that basically means is think about reflecting it over the y-axis and then over the x-axis. Note that sign is odd. And again, here you might not know what negative f of x means. Well, all this means is if we have a function written as y equals, let's just write it as negative y equals. So here for sine, if I wanted to write f of negative x, I'd simply write negative y, just changing y, equals sine of x. So note, guys, that sine of negative x equals negative sine of x. And so if the negative y thing confuses you, you can just multiply whatever f of x equals by negative 1. So again, going back up here, if I wanted to find negative f of x, I just multiply everything by negative 1, and I get negative x squared plus or minus log of x. Alright, so let's do a quick practice problem. Is a function y equals 3 to the x even, odd, or neither? So pause your video, unpause when you think you've got the answer. Alright, so what you should have gotten is that this one was neither. So if you did get that, you can fast forward through this. But if you didn't, stick around for the explanation. Hopefully I can clear up any confusion. So we know that for this to be even, f of x must equal f of negative x. So a good way to see if this is true is let's just write out f of x and f of negative x. So again, anytime we see x, we're replacing it with negative x. There's only one x here, which I'm replacing with negative x. So what this is saying is that 3 to the x equals 1 over 3 to the x. And this is only true if x equals 0. For a function to be even, this statement has to be true for all values of x. So since this is only true for x equals 0, this is not even. Alright, so we know that if this is odd, f of negative x must equal negative f of x. So here, let's write out f of negative x, which we know 3 to the negative x, and negative f of x. So let's just multiply this through by negative 1. So equals negative 3 to the x. Now if we simplify, this looks like it could be true, but we're going to see that it's not. So 1 over 3 to the x equals negative 3 to the x. And so if I plug in, say, 1, I would get 1/3 on this side, and on the other side I'd get negative 3. And these are not equal. So this is not odd, excuse me. Alright, so let's talk about inverse functions now. The inverse of a function is found simply by switching the x and y variables and solving for y. So we have this function y equals x cubed. If we want to find its inverse, we're going to switch x and y. So say x equals y cubed, and then solve for y. We're left with y equals cube root of x, which we can see our graphs right here. This one, see if you can see that y equals x cubed and y equals cube root of x. An important note about domain and range of inverse functions. So let's say we have some function here with a domain of 0 to 3, and its range is all real numbers. Guys, note that if we write infinity in domain and range, we're always using this parentheses. You would never use a square bracket. That would be incorrect. So never say write this, because that would be wrong. So if we have this function's inverse, and we want to find its domain and range. Now this might seem a little complicated at first, but it's actually really simple. We're just going to flip these from the function itself. So the domain of the inverse is the range of the function, which would be negative infinity to infinity, and the range of the inverse is the domain of the function, so 0 to 3. Make that a little more clear. That is the bracket symbol. Alright, now let's talk about the one-to-one rule for inverse functions. A function has an inverse only if it is 1-to-1, meaning that for each y value on the function, it only has one corresponding x value. And this can be seen by using what's called the horizontal line test, where we're drawing horizontal lines on the graph. And a function fails a horizontal line test if these horizontal lines hit the function in more than one spot. So we can see here that on y equals x cubed, this is only hitting on one spot. So it passes the horizontal line test. Well, y equals x squared, it's not. So this is not 1-to-1 because this is hitting, these horizontal lines are hitting the function in two spots. You can also see this analytically with y equals x squared or any function that isn't 1-to-1. So let's say we plug in -1, 0, and 1. At x equals -1, we have y equals 1. At x equals 0, we have y equals 0. And at x equals 1, we have y equals 1. And we can see that at these same y value, we have two distinct x values. And so this is not 1-to-1. I could also solve this, solve for the inverse. I'll switch x and y, so x equals y squared. Take the square root of both sides, and I'm left with square root of x equals plus or minus y, or y equals plus or minus root x, which we know is not a function. So therefore, this inverse function does not exist. Alright, so now let's talk about the absolute value function, and this is denoted by these two vertical bars here. And all this means is that whatever comes into these vertical bars is going to come out positive. So if I have the absolute value of -3, this is just 3. If it's already positive, it's going to stay the same. Also note, guys, that this can be written as the square root of x squared. So just something to know, this is a lot easier to work with in terms of algebra than this. So just know if you see absolute value, you can also write it as square root of x squared. Alright, so now let's talk about the greatest integer function, which is denoted with these square brackets here. And this function simply means that graph the greatest integer that isn't greater than x, or whatever is inside of these brackets. This isn't very common to see, but you should sort of know what it means and be able to recognize it in case it does come up on the AP test. So if you're confused by this, let's just draw a little table here, and we'll have 0, 1/4, 1/2, and 1. Now, so if we plug these in here at x equals 0, all we ask ourselves is what is the greatest integer that isn't greater than 0, which is 0. 0 is the greatest integer not greater than 0. At 1/4, the greatest integer not greater than a fourth is still 0. Same goes for a half. But at 1, now 1 is the greatest integer that is not greater than 1. So we can see sort of this staircase shape where at the integers it's jumping up. Also note that I'm not sure why this is a closed dot. That should be an open dot. Again, this is not something that's very common, but you should definitely sort of know what it means and understand it. Alright, now let's talk about exponential functions. So these are denoted as y equals a to the x, where a is a real number. Functions that are exponential follow this basic pattern. Note that functions like y equals x squared are not exponential. They're polynomials. So what we need for an exponential function is we need some number to some variable. Note that any number to the 0 power is equal to 1, and if we have something to the negative of that power, that simply means 1 over something to that power. So a to the negative x equals 1 over a to the x. Now let's talk about logarithmic functions. These are denoted as y equals log base a of x, where a is a real number. Note that logarithmic functions are the inverse of exponentials. So if a function has no log base, which is this a right here, we should assume that it's 10. So if you see log of x, just assume log base 10. You should also know about log base e. This is called natural log, and it has its own symbol denoted as ln of x. E is a constant called Euler's number. If you don't know what Euler's number is, that's fine. We'll talk about Euler's number more in later videos. But just know ln equals log base e. Alright, now let's talk about log rules. So the first one to know is that log of x times y equals log of x plus log of y. X and y can be anything. They can be numbers, they can be functions, they can be variables, whatever. Similarly, log of x over y equals log of x minus log of y. Log of x to the y equals y times log of x. So we're simply just moving this exponent out to the front and multiplying it. Log of 1 is 0. Log base a of a equals 1. And now pause your video and try to figure out what log base a of a to the k is. So pause your video, unpause when you think you found the answer. So what you should have gotten for this is that this equals k. And I can find this simply by using this log rule right here. So log base a of a to the k. Let's take this and multiply it out in front, as shown in this log rule right here. And now I can recognize this as over here, and we get k times 1, or k. Also note that a to the log base a of k is just equal to k. Now you're probably wondering, well, why are logarithms the inverse of the exponential? So let's say we have y equals a to the x. Why is y equals log base a of x the inverse? Well, if we switch x and y, we get x equals a to the y. Take the log base a of both sides. And we're left with this on the right-hand side. and the k here is y, so we just get y equals log base a of x. And this leads me to my final log rule, that if we have y equals a to the x, this can also be written as log base a of y equals x. So a good way to think about this is we're simply taking this x, which is higher than the a in terms of writing, we're just sort of moving that over and it becomes the exponent, and moving this y to the other side. If that confuses you, then maybe you just want to memorize this right here. Alright, now let's talk about trig functions. We have 6 main ones: sine, cosine, tan, cosecant, secant, and cotan. Cosecant is 1 over sine, secant is 1 over cosine. Note that tangent is sine over cosine, and cotangent, as you would expect, is cosine over sine, because cotangent is also 1 over tan. There's some vocab you should be familiar with. The amplitude is how high the function goes. So this length right here, here, and here, this is our amplitude. Amplitude only applies for sine and cosine, only for sine and cosine. So say tangent, cosecant, etc. does not have amplitude. This can be determined very simply if we have y equals k cosine x. K, or absolute value of k, is the amplitude. So up here, we have y equals cosine x, or k is equal to 1, so our amplitude is 1. And you would find the amplitude of sine in the same way. Period is how long the function takes to repeat itself. And so I can write this out as y equals cosine of kx. Kx equals 2 pi. X equals 2 pi over k, and x is our period. This works for any trig function except tan and cotan. So we'll say for tan and cotan, we can say y equals tan of kx. Kx equals pi, and x equals pi over k, and again, x is our period. So we'll see up here in y equals cosine of x that kx equals 2 pi, and if we solve for x, in this case k is equal to 1, we see that x equals 2 pi. So our period is 2 pi. And if I trace along the graph to 2 pi, I can see that right there, that's when the graph starts to repeat itself again. Alright, so now let's talk about some trig identities you should know. These first 3 are called the double angle identities, and this one down here you're probably already familiar with. And these are the 4 that you should know. Now you might be thinking to yourself, there's a lot more that I've missed here. But really, you can actually find the other identities by using these. So let's divide this last one by sine squared. Sine squared u, that is. Sine squared u. Well, this first one, cosine over sine, that's cotangent. And since these are both squared, that first term is cotangent squared u. Sine squared u over sine squared u is just 1. Just 1. And 1 over sine is cosecant. So here we're left with this identity that you've probably also seen, which we just got by dividing this one by sine squared u. I can also divide by cosine squared u and get the last one that you're familiar with. Alright, so let's go over some other trig formulas you should know. 1/2 AB sine C equals area of a triangle. So if I have these angles here, A, B, and C, these can go anywhere, and we have their sides directly across from the angle. I can get the area of this triangle by using the formula 1/2 AB sine C. This is one that you should know because a lot of problems you do can be made much easier by knowing this formula. You should also know the law of cosine. C squared equals A squared plus B squared minus 2AB cosine C. Again here, C, A, B, 2AB, these are all sides, and this C here is angle C. And again here, this is angle C. Alright, so let's talk about inverse trig functions now. Inverse trig functions are exactly what they sound like. They're the inverse of their respective trig functions. These can be written as y equals whatever operator we have, which in this case is cosine, and this -1 right here, or by adding the arc prefix. So if you're curious as to how I'm getting that, so if we have the function y equals cosine x, I switch x and y, I get x equals cosine y, and if I take the arc cosine of both sides, well, one too many c's here, apologize about that. Arc cosine x equals arc cosine of the cosine of y. And these are going to cancel, and we're left with y equals arc cosine x. Now an important note about the domain and range of the inverse trig functions. Since all trig functions are not one-to-one, their inverse function's domain and or range is restricted. Alright, so that leaves us with today's challenge problem. Is f of x equals x squared plus sine x over x to the fourth even, odd, or neither? The solution is on our website, learn-AP.com. The direct link is also in the description. If you found this video helpful, please like and be sure to subscribe for future content. Like us on Facebook and follow us on Twitter for updates about our new videos and live streams, which we do every Sunday from 4 to 5 p.m. Eastern, where we answer your questions about AP Calc. Links for that will also be in the description. If you're looking for other resources to help you learn AP Calc, be sure to check out our resource recommendation video. Leave a comment if you're still confused about anything, or also any other comments on the video in general. Other than that, I want to thank you guys for watching, and I'll see you in the next video.